So without further ado, I'll be sharing with you the very first problem statement out of 6, right? The first problem statement is independent wheelchair transfers. Now, for some of us, using the toilet is a simple, everyday task for most of us. You open the door, you close the door, you shift yourself onto the toilet seat. Once you're done, you flush, you wash your hands, and then you leave, right? But it is not as simple for our friends who have early to mid-stage motor neuron disease, or MND for short. Now, they typically maneuver in wheelchairs and may have insufficient upper body strength to hoist themselves off the wheelchair and onto the toilet seat, which when done independently might risk hurting themselves. And some caregivers might also be elderly or unavailable, which creates a very dire need for this problem statement to be addressed. And the community behind this problem statement is none other than the Motor Neuron Disease Association, or MNDA for short, who is a group of patients with MND, volunteers and caregivers who have dedicated their time to support this cause. This is such a need and a very apt beginning to a full day of learning of these amazing inventions that will be shared throughout the day, solving real-world issues and serving real-world needs. So without further ado, let's have our first team up, Team SKSS.
Hello everyone. Sorry. I'm Felicia. This is Minako. This is Wayne, and this is Wan Lek. We are from Sengkang Secondary School, and our group name is SKSS2. So as you know, our problem statement is independent wheelchair transfer. We are supposed to try to design some products and try to develop some ideas to help people who have motor neuron disease. So this is our product. It's called the Zip Chair. It features a transfer rail that allows the user to zip from one side to the other side effortlessly. This product is more for mid to early stage patients, and mid to early stage patients to transfer themselves, and it is very durable enough to hold up to 90 kg in weight. So this is how it works. The user will place the ramp between the wheelchair and the place they want to transfer to, and they will use it. They'll sit on the seat. Then they'll use their arms to slide from one end to the other end of the wheelchair. One example is this: that they can place it between their bed and their wheelchair, and they can use their arms to slide and transfer themselves. So I'll show you a demonstration. So Wan Lek over here will act as the MD and patient. So I'll show you the weight. We have a weighing scale. So first you will take his weight. He's 49 kg. So sorry. Then we'll have Minako also. He's 46. So this product can hold up to 90 kg in weight. So let's test it out. Can you guys sit on it? Wow. Yep. So Wan Lek will now show you how to use the product. So he was supposed to sit on the seat. Then he will use his arms to push himself to the other end of where he wants to go. Go back. This wheelchair is quite practical. You can bring it around anywhere, and the user can just use it by him or herself. So after seeing this product, why I think you should vote for us is because I feel that it's quite beneficial and quite useful.
Hi everyone. So my name is Anson. This is my brother Anton, and we're from the team 36 engineers. So we have two more members, Maden and Ting Xian, which unfortunately can't make it today because of their midterm exams. So we are. Okay, wait. Okay, so we are a team from different walks of life with a common passion to help others. And then most of us met under the Unit 36 Combat Engineers in Army. That's why we are called 36 Engineers. So, yeah. Also, we want to give a special thanks to our honorable member, which is Darin, Chris Lobo, who helped us with a lot of the welding and engineer stuff overall. So, this is our problem statement. What are we trying to solve? So, of course, we want to transfer patients from one surface to another. And we're going to try and do it while reducing pain while transferring patients. And not only that, to transfer to a wide variety of places. So our end users will be those who are suffering from motor neuron disease and those with weak upper body strength as well. So after talking to our community partners, here are some of our considerations. But I think the most important takeaway was to reduce pain when moving. And so we decided on this model. So this is our proposed solution. You can see your cut model. Yeah, so we made this little laser cut model at the start, which is over here. So how we decided on creating this product is we combined two solutions into one product. So which was a transfer board that we found online. We saw online, you see this little bubble at the second bubble. That's the transfer board we found online. And we also have this foldable armrest. And so we thought of combining those two ideas into one product. And not only that, we wanted to make this height adjustable as well. So in the future, we also want to add maybe some more straps, some more cushions, or even a power supply for supporting devices as well.
So you hold this. Okay, so for our model, this is our first prototype that we made. So it was laser cut and then put together. So it's kind of like Legos. But basically, the main purpose is to show how the function of the wheelchair will work. So basically, the armrest folds downwards, and then you can slide from the center of the seat to the armrest. So you can be transferred from there onto like a toilet or the bed. Yeah. So this is us building it. That's us in a workshop, and that is the wheelchair that we managed to find. Yeah. Okay, then this is our main drawing that we did. It's kind of hard to understand right now, but basically, we wrote down all of our plans that we wanted to achieve for the wheelchair. And the picture there is the cat that we put on top of the wheelchair. And this is us making the wheelchair. This is how it looked like at first. It was quite sad. But then, as you can see now, it's very nice. Yeah. And that is us making the wheelchair, using all of the equipment and stuff. It's quite cool. And this is the mechanism that we wanted to use so that we can adjust the height of the wheelchair. So we're supposed to use an actuator to make it so that it can extend. Okay, yeah, show example. Yeah, so this is the actuator that is supposed to push it so that as you can see from there, it can be height adjustable so that it can match like the surface of like your bed or like a chair or anything like that. Yeah. And this is also the main function of the wheelchair. So as you can see from the smaller one, this is basically like a bigger version of that, which is it's just a lot better and it moves a lot smoother and it won't get stuck.
So I'll go to a short demo of the wheelchair. So let's say you have a chair here and you want to move the patient onto the chair. So what you will do is there's this little latch over here. You can take out the latch and the armrest will fall down. Then you can move the patient from here to the wheelchair itself. Sorry, to the chair itself. Then you can move the patient gently over to the chair. Yeah, then you move back. Then you can relatch it. Yeah. This also works for the other side, but we don't need to show it twice. If it works, it works. So, yes. Okay. Next slide. Alright, so in the future, we also want to implement some more things, such as making the wheelchair lighter. Right now, we're using steel for the height adjustable mechanism, which is very heavy, so it's not very portable as well. I pushed it on MRT towards here, so I know it was not very easy to push. However, we also want to add some modularity to it. So in the future, if you want to make this thing modular, so you can add it to an existing wheelchair, that would be also great. And also, you want to minimize pain for other users, such as adding more straps to the legs or somewhere on the body itself. That's it for our presentation. Thank you, guys. Thank you. Good morning, everyone. We are Team MS Paintbrush, and we're here to share with you our project called Auto Hoist and Sling. So, who are we? We are a group of 5 NUS High students who came together over a mutual interest, and that is using innovation to help others. In addition, we also receive a lot of support from our community partner as well as mentor to make this project successful. Now, on to the problem statement. Our problem statement is called Independent Wheelchair Transfers, and we are tasked with improving the independence for MND patients when using bathroom facilities. So, what is MND? MND stands for motor neuron disease, which is a rare neurological disorder, and it is caused by the progressive deterioration of neurons or nerves in the brain as well as in the spinal cord. Symptoms of MND vary from patient to patient and can arise in the form of weakness in arms or hands, foot drop, loss of voice, breathing difficulties, or loss of muscular and motor controls.
Next, our community partner, Mr. Ui Lin Ka, was diagnosed over 10 years ago. Currently, he is a late-stage patient of MND. Hence, he is completely paralyzed except for his eyes. However, his mind is still active and alert as MND does not affect his cognitive abilities. So, since he is a late-stage MND patient, we thought that independent wheelchair transfers were not applicable to his condition. As such, we changed our goal instead to an automated motorized sling and hoist system that allows MND patients on the bed to independently transfer themselves. The first problem that he faces is the manpower needed. The transfer process is currently very labor-intensive, and he requires at least 2 caregivers to transfer him from the bed to the hoist, which can possibly give the caregiver backaches or physical pain. The second problem that he faces is that the transfer process actually takes a lot of time, and every time that he wishes to use the commode, which is the kind of toilet, he must be placed into a sling and mounted onto the hoist before he can be hoisted from the wheelchair to the commode. So this entire process requires a very long time, and some people with MND actually choose to remain in their slings for the entirety of the time. Yeah.
So what is the solution to this problem? Well, this is what the auto hoist system is for. This system features improved hoist and sling. With this new hoist, it's fully powered, moving laterally and hoisting via motors. Along with the additional circuitry, this allows MND patients to move themselves, controlling the movement through their eyes. The end result is reduced intervention from caregivers and improved sense of independence for the MND patients. The new wearable sling integrates the component of sling into the standard jumpsuit. Now, all caregivers need to do is to clip the straps from the hoist to the rings of the jumpsuit. This design allows the person with MND to experience greater comfort with a sling designed for long-term wear.
Let's not talk about our prototype. Our prototype is scaled down physically and in terms of features relative to the full auto hoist system. It features an Arduino-based robot, which is our sling, our hoist. This Arduino-based robot has a wireless remote control to control its movement and the hoisting of the hoist. Additionally, we also have a sling for a small tiger stuffed toy, which will serve as our prototype. Next, let's see a photo of our prototype. We will now have a live demonstration of our prototype. If you are unable to see the live demonstration on stage, you can also refer to the video on top. Thank you. So, the hoist itself can move forward, backward, and turn to both sides. Let's see that in action. It can also change the height of the actual hoist itself. Yeah, sorry.
I'm gonna take all the way out. I'm going to shake like hell.
Next, let's take a look at the sling. The sling is for a stuffed tiger teddy bear. On the sling itself are metal rings and hooks to hook into them. When the hooks are hooked into the rings, this can act as a sling itself. That's an example of someone hooking it into the sling. Next, what did we learn through this? Firstly, sympathy. As we do not have MND, we had to talk to our community partner to understand his needs. We also learned skills like Arduino and design thinking. And lastly, throughout this process, we gained a lot of knowledge about motor neuron disease.
So what is the next? Firstly, we want to utilize AI to hook the harness up automatically. This allows patients to be fully independent without the need of the caregivers. And secondly, development of eye tracking. This allows patients to control their hoist on their own, even for the late stage patients. We have come to the end of the presentation. Thank you. And if you have any questions, please visit our booth at MS Paintbrush.
Test. Okay. Hi everyone. Hi, we are Team X4XYZ. My name is Shayna. She's Kaishen, and we are from Applied Materials. Yeah. So let's present our solution, which is roll with ease. Yeah. So before we begin with our solution, let me go through and unpack the problem once again. Because throughout our journey here, we decided to sort of reframe the problem after talking to our community partner. So this problem statement came because people with MMD may not have enough body strength to help themselves to transfer from the wheelchair to the bed or the bed to the wheelchair, and typically require at least one caregiver to assist with this transfer. So the current method of physically lifting the person from the bed and placing him on the wheelchair is very physically taxing for the caregiver and requires at least 2 people to help this task. There are also solutions available to assist with this, but they tend to be not very cost effective, and they also tend to be still quite not very ergonomic for the caregivers. So essentially, as we were approaching this problem, the question we had in mind was how can we help caregivers transfer a person from the bed to the wheelchair independently, and ideally this would ease the task ergonomically, be cost effective, and allows one person to do it instead for the caregiver side. Yep. So now Kaishan will bring us through our solution.
Thank you, Shayna. So today I'll be bringing you through the solution, which is called Roll with Ease. So we prototyped this completely through 3D printing, and we would like to look at this as a combination of a bed and a wheelchair together. So this comes together as a set, and it solves the problem of cost effectiveness and also the problem of ergonomic usage. So we're looking at it from the caregiver point of view, where there is only one caregiver required in this aspect. So we took inspiration from our everyday objects in order to design this actually. So if you look at it, we have rollers installed under the bed. So this actually helps to roll the cushion from the bed to the wheelchair and vice versa. So these rollers were inspired from our own production line in manufacturing, where we were looking at how materials were moved around in our own clean room. So using this aspect of mechanism, we integrated it into our own solution in order to move a weight from one place to another. So using that would be the roller mechanism. So the second mechanism in place would be how the different pieces of frames are actually connected together. So we used hinges. We used the idea of hinges to connect them, and this would be taken from the door hinges that we see on an everyday basis. And actually, if you look at the back of the chair, which would be, the back of the bed, which would be on the bottom left of the screen, you can see that there is an adjustment mechanism for the top frame of the bed. So this was taken from gym chairs, where you get to see that people adjust the angle of their chairs. Yeah. So for this solution, you can see that we completely 3D printed it, and then you will start off with the bed. So the patient will be on the bed first, and then you will have the seat strapped using Velcro straps to the bed, the sides of the bed. And then you will adjust the seat upwards, and then strap the Velcro upwards as a seat belt also. Then we will start using the roller system, and then roll over to the right side onto the wheelchair. So I believe that this is just a very small step towards achieving a better solution for such independent wheelchair transfers from the perspective of the caregiver. So
yes, we are using simpler mechanisms that we see on a day-to-day basis, but it's very important for us to look out for these mechanisms such that we can slowly and incrementally improve the objects that we see and also improve and work on the problems that we have daily. Yep. So with that, thank you, and we hope that you have a good Saturday ahead. Thank you.
Thank you, Team F4XYZ. Thank you, thank you. Those in FB Live also, please clap for them. I think they did a very good job. The illustrations are all very nice. Now, we're coming on to the last team for this particular problem statement for independent wheelchair transfers. This team has a very interesting name, but I'll bring them on here first before I ask them a bit more. Right, can we give a round of applause to this team called Existential Engineers? While they're pushing, I just want to ask you a bit more. So why do you, what's with the name Existential Engineers? How do you guys come up with it?
Because we are engineers and we believe that our solution is good for the existence of these people with MND.
Ah, okay. I thought something to do with existential crisis. Not lah. Well done. Right. Without further ado, your time is yours.
Good morning, everyone. I am Aloysius. With me is Jonathan, Daksh, and Ravin, and we are all Sec 3 students from the School of Science and Technology. So, about our problem, our target user is people with motor neuron disease, or MND for short. And what this is people with MND would lack the upper body strength to move around. And symptoms of MND can include weakness in their ankles or legs or slurred speech, and sometimes the inability to swallow. So our solution, this is a wheelchair named Klotsky, which I will explain why later. It is a modified wheelchair that can be adjusted to ramp for wheelchair users to slide to and fro from their wheelchair, all while being perfectly contained within the wheelchair itself. It is comprised of wood, a wheelchair, and electronics on the underside. So our total cost would be $260, majority of which is for the wheelchair at $140. And
okay, so now we're moving on to the live demo stage, where as we can see, this is our current wheelchair. So first what we do is that we will bring up the wooden board that we have. So the person has a place to slide on top of. And then from there, we'll put down this wooden leg that you can see. And from there, this wooden board will move so that the person can slide to the chair which he needs to be sitting on. So with this, we have also made the seat actually removable. So we can actually make it perfection. We can actually have it perfect to each individual user. So after this, we have also made it even foldable, so that you can actually fold it up and bring it onto transportation, and whatever you need to, it will most probably fit.
So now we're talking about the future modifications you can do to this wheelchair. One thing you can do is use a longer wooden board so the person can slide further from the wheelchair itself. Then we also have the voice control movement. We have already coded this out. However, we were unable to implement it in the wheelchair itself because we lack the expertise to do so. And we can use stronger materials and use pistons to support the person itself and lift this wooden board automatically.
So I said just now, I will explain why it's called Klotsky. Klotsky is actually a sliding puzzle game that originated in China, which is, it slides, so sliding. Anyways, thank you so much.
Thank you.
All right, thank you, Team Existential Engineers. And this is the last team from the independent wheelchair transfers.